This is 1-3, measuring and constructing angles. So I'm going to look at the warm-up where I have to draw, number 1, draw ray AB and ray AC, where A, B, and C are non-collinear, so they can't be on the same line. So here's a good example of that. Draw opposite rays. Remember, opposite rays form a line. So opposite rays DE and DF. So there's an example of opposite rays. Example 3, an algebra review question. We can combine like terms, so 2x, x, 3x, all on the left-hand side can be combined. So 2x plus x is 3x, plus 3x is 6x. Then we could combine 3, -4, and -5. Well, 3 and -4 is -1. -1 and -5 is -6 equals 180. And we could start solving, add 6 to both sides. 6x equals 186. To finally isolate x, get rid of that multiplication by dividing both sides by 6. And we end up getting 31. X equals 31. Okay, and for example 4, we are simplifying on both sides. So what I need to do is get the variables to the same side. So I'm going to subtract 8x from both sides. You could have moved 5x instead if you wanted to avoid that negative. Now I'm going to subtract 2 from both sides because this is what I'm isolating. So -3x equals -12. Divide both sides by -3. And x equals +4. Okay, here we have some new vocabulary. So an angle, like this one, is formed by 2 rays, so ray RS and RT in this case, with a common endpoint. The common endpoint that they're sharing is R. It's called the vertex. If we have more than one vertex, we would say vertices. The set of all points between the sides of the angle is the interior, inside the angle. The exterior of the angle is the set of all points that would be outside the angle. Okay, and we can name this angle by a few different ways. We can name it by the vertex, so we could call it angle R, or we could name it with 3 letters, but the vertex has to be in the middle. So I could call this angle SRT because the vertex is in the middle, right? That angle R right there. And then angle TRS is another option. In addition, sometimes there's a number inside the angle, in this case the 1, so I could also call this angle 1. Okay, example 1, a surveyor recorded the angles formed by a transit, point A, that's going to be our vertex, and 3 distant points, B, C, and D. Name 3 of the angles. So if point A is the vertex, then we're looking at something like this, so we could call that angle BAD, or angle A, or angle DAB. Same thing here, we've got, another option would be angle BAC, angle CAB, or angle A. And then our third option could be, each time A is the vertex, right? So it's angle A again, or it's angle CAD or angle DAC. I'm going to skip the protractor information for now because we're going to work on that in class. So types of angles. We have acute angle, right angle, obtuse angle, and straight angle. You may have heard of these before. Acute angle is less than 90. Some people say it's cute because it's small, so acute angle. Right angle must measure 90 degrees, so less than 90. Must measure 90. And obtuse must be greater than 90 but less than 180. Because if it hits 180, then it's a straight angle, a line, basically opposite rays. Okay, congruent angles up top here. Congruent angles are angles that have the same measure. The word congruent we've already learned meant same, right? Arc marks are used to show that the two angles are congruent. So before, when we had segments, we used tick marks, but now we're using arc marks, which look like this, those red marks there, okay? And so I know that angle B is congruent to angle E, I could say, or I know that, let me get my pointer out, I know that angle ABC is congruent to angle DEF, or I could say angle CBA is congruent to angle FED, for instance. We just have to make sure we are understanding how to name these angles appropriately. Okay, angle addition postulate. This is very similar to segment addition postulate, where we had two segments that add up to the total length. Here we're going to have two angles, this blue angle and the red angle, that add up to the total angle. And so what that looks like in this case is we can't call this angle Q because there's two angle Q's here. I have to really specify. If I'm saying angle Q, I'm not sure if I'm talking about one of these small ones or the large angle altogether. So what I would call this blue angle is RQS, keeping the vertex in the middle, right? And then to name the red angle, I could call it SQP, and to name the whole angle, I could call it RQP. So that's what this angle addition postulate is saying, that angle PQS, the red one, plus angle SQR, the blue one, is equal to the measure of the whole angle PQR. Okay, so let's look at some examples here. I know in this case DEF plus FEG is equal to DEG, the total. So the two small equal the total. So let's look at what we have. I like to write it right in the image. So DEG, this total piece, is 115 degrees. And DEF, this angle right here, is 48 degrees. Find the measure of angle FEG. Well, FEG, since we don't know it, I'm just going to call it X. And I'm going to give it two arc marks so that I see that they're not congruent, because I'm not sure that they're the same measure. Okay, so I would have 48 degrees plus X degrees, the two small angles, equal the large angle 115, and then from there I can just solve. And X equals 67 degrees. So really what I was answering, so going back to the question, said find the measure of angle FEG. So the measure of angle FEG is equal to 67 degrees. Okay, an angle bisector. We've seen the word bisect before. By two, right? It's going to cut into two. An angle bisector is a ray that divides an angle to two congruent angles. So this ray JK is the angle bisector. It says JK bisects angle LJM. If that's true, then it creates two congruent angles. So these would have the same tick marks. I don't like that they really just colored it the same. So I'm going to add in some tick marks here. That one is congruent to that one. Okay, find the measure of each angle. So our angle bisector, it says, is KM. KM bisects angle JKL, which means that it has created two congruent angles. Measure of angle JKM is 4x plus 6, which means that I know that MKL, remember, is going to be the same measure, but it's saying here MKL is 7x minus 12. Since we know that they're the same, we can set them equal to each other. So 4x plus 6 equals 7x minus 12. This is why we need to be remembering our algebra. So I'm going to get the variables to the same side. I'm going to move the 4x this time to keep my x positive. So we get 6 equals 3x minus 12. Now I have to get the numbers to the other side, so I'm going to add 12 to both sides because I'm trying to isolate that x. 18 equals 3x. Now to get x by itself completely, we've got to get rid of that multiplication, so we divide both sides by 3, and x equals 6. And so let's make sure we've answered the question, because if I go back If I left my answer as x equals 6, I'm actually wrong because it says find the measure of angle JKM. Well, JKM, remember, was 4x plus 6. 4x plus 6. The measure of angle JKM equals 4x plus 6. So that equals 4 times x, which is 6, plus 6 equals 24 plus 6, which is 30 degrees. I'm just going to make sure that makes sense based on the image. Well, it is an acute angle, so 30 degrees does make sense.